go.
Okay, looks like he is. Okay.
Okay, great.
Okay, really sorry for this one. So as I said, we're going to talk about fine-tuning, and we're going to ask, is it like an old practice from the times that AI was, you're training models for going into production, while, with prompt engineering, you can still achieve amazing results? Or is it something that's really necessary in order to achieve business value in production? My name is Gad. I'm the founder of TensorOps and CTO. I'll be the host for the session, and we have Jeff Don from Google. Hey, Jeff, how are you doing?
Hey, great. Thanks for having me again.
Um, Jeff, maybe a little bit about what you do at Google.
Yeah, absolutely. So I'm a partner engineer at Google. So what that means is I work very closely with partners such as TensorOps to understand their technology strategy, share Google's technology strategy, see how we can accelerate things together. My focus here is data and AI. So everything AI is near and dear to my heart. So I'm excited to talk later today about how we fine tune on Google.
Amazing. And we also have Miguel from TensorOps. Miguel, want to say a word or two about what you do at TensorOps?
Yeah, absolutely. Hey everyone. So, like Ed was saying, I'm at TensorOps. I'm an AI solutions architect, meaning I help companies build the products from idealization to then development to overlooking everything, giving advice, all of that, all of the above.
Great. So, Miguel, I'm just going to give it to you. Why don't you talk to us about what is the agenda for today?
Yeah, perfect. So, of course, we're going to do a overview of fine tuning, or it wouldn't be a fine tuning webinar, right? And then I want to talk about a bit about prompt engineering versus fine tuning. Of course, a lot of people may already know a lot about this, but it's about the strengths of each one, the use cases, etc. Then we're going to look at a real case that we brought here. So it's so that we look at a real case and we study how fine-tuning impacted it, what was the business value, results, etc. And then, of course, one of the most important questions here, which is when to actually use it, right? Is it just a buzzword? Or when to actually use it? We're going to present some common pitfalls in the decision making and also a decision framework that you may take some ideas from to apply to your projects, your company, whatever is your use case, right? And then, of course, like Jeff was saying, we're going to give off some general advice on fine tuning. We even have a small demo for you on how to do it on Vertex AI, which I'm very excited for, Jeff. Yeah, it's going to be a good one. Okay, so without further ado, let's get into it. Let's start with the most basic question, right? What is fine tuning? Now, of course, fine tuning is the process of not training the whole model from the beginning, but just training the model after the initial training to adapt its behavior. Now, this can mean training all the parameters, just a few of them. It's about fine tuning its behavior. And a great example of this, which is very famous by now, is like, okay, so we have these chat models, right? We ask them a question, and the base model will answer. Sometimes in a short way, it will answer however it learned from the dataset. But it may not be how we want it to answer. We may want it to be formal, we may want it to answer in a specific format, more extensive, more short, etc. And that's where fine-tuning comes in to make this possible without you having to ask for it in the prompt, right?
Miguel, so one thing that I think already pops to my eyes here, you have the base model, you had a fine-tune model. Is there a correct answer in this regard? So when I'm seeing the differences between the two, what makes the fine-tune model look like that versus the base model?
Yeah, like you were saying, the question of is it better or not? I guess it depends on the use case. Does the user just want a short answer or not? And what actually will make the model learn to answer more extensively or in more details is it's dependent on the data set that you give when fine tuning, right? So it depends on the task that you want, the data that you want, the examples of outputs that you give.
I see. So it's not about, so when you're talking about, for example, model training, you think about a correct answer versus an incorrect answer, right? A quality versus not. And fine-tuning is really about taking the model and kind of like getting the behavior that you want from it in the context of your use case.
Exactly.
Okay.
Sometimes it's harder to know when it's the right answer or not, right?
Okay. Yeah.
Okay, great. So just like you were asking about, Gad, data is a real critical process here, right? Because it defines on how the model will actually train. So which data should you use for fine-tuning? Now we know the kind of data that they use for model training, these foundational models, right? They just throw everything in the internet at it, whatever you find. You don't need to treat the data. You don't need to clean it so much. It's like, okay, in this picture, of course, it's a dumpster. You can make it a bit prettier, but it's like whatever you find. For fine-tuning, though, it's much more important to have critical examples of your specific use case on input and output that you want. Like God was saying in this previous example, if you want detailed answers, you need to have a question and then a detailed answer exactly how you wanted it to be structured, bullet points or not, etc. And this is where high quality data comes in. This is why fine-tuning sometimes it's hard. It's because it's hard to find this quality data for your specific use case. So now I wanted to analyze prompt engineering and fine-tuning over some of these axes right here that we have on the screen and which I'll discuss in a bit. Okay, so of course we've heard a lot and we know a lot about prompt engineering. All of us, we've been playing around with these LLMs and models. What is it best for? Or what is it not so good for? Now, some of the things that I would say it's not its strengths would be prompt engineering isn't really that useful for adding knowledge. So you can add context about your problem, right? But you're not going to teach it most times like a whole new language or a whole new, I don't know, branch of science or something, right? You can teach it small stuff about your problem. Same with information security. Prompt engineering isn't exactly the tool for this, right? Making the model smarter, well, you can try to beg it to be smarter, but it probably won't pass much more than that. Lower latency and costs, well, the bigger prompt you have, you may increase accuracy, but then you're paying more, you're making it more slower, right? It's pretty obvious. Then, of course, you have formatting. Now, this is where it gets a bit mixed up, because it's like, it kind of works. So for example, in the initial example, you could ask in the prompt for it to make it detailed. But then let's say you wanted to print out a JSON response. You really have to say, oh, please answer me a JSON. Please don't mess it up. Please make it a JSON, right? How well does it work? Well, right, it depends. And then you have the strengths of it, right? So these are the obvious use cases that you can use it for. Increasing the accuracy for your specific problem, because you tell it exactly what you need, what you want. Adding context on your problem, so it could be about your company, your users, etc. Asking to answer in a specific way. Okay, so I think this is all pretty straightforward. So now let's talk a bit about fine-tuning and how it exactly distinguishes from the previous one. So fine-tuning, same as prompt engineering, isn't really that good for lack of knowledge or for adding new knowledge, right? Because you can add specific knowledge about your problem, but you're probably not going to teach it a whole new domain, a whole new thing. Information security, then again, it's probably not the best tool. Now here I have some things which are also a bit questionable or not, can be argued both ways. Making the model smarter. Well, most times I would say no, fine-tuning is not for this, but now we have seen a lot of techniques, and we'll discuss some of them here, like knowledge distillation, where you can use a smarter model to train a weaker model and actually make it smarter at some things. And then accuracy, well, you can use fine-tuning for improving accuracy, but it's not always guaranteed because sometimes you're using a smaller model, etc. So it really depends on your use case. And lower cost and latency, I would say most often yes. By fine-tuning, you will probably even use a smaller model. You'll manage to use a smaller model, and then you'll end up paying less, having lower latency, etc. But what it really excels at is formatting. So if you want those JSONs that I was just talking about, or whatever format you need, this is where fine-tuning really comes in, and it's one of its biggest strengths. Adding the context is also something really good. So adding the context about your specific use case so that you don't have to repeat it in the prompt every time you go to the model, right? And then tone, making it more formal, more casual, etc., etc. So now I have a provocative question for all of you to think about, which is that we see a lot of products nowadays coming up, and essentially what they're doing is they're wrapping an LLM API, right? So they have sometimes really good software, really cute UI, etc. But while they present themselves as AI software, the actual developers sometimes don't even mess that much with AI, right? They are just using an API. Nothing wrong with that, but I just want to ask some provocative questions here. First one, let's look at it. So one of the main questions is, if you're just wrapping it and you're not actually putting your hands into the AI, are you actually tapping into the full potential? I mean, you're using a model that was trained to do everything, right? A very generalistic model most times. And while it may be very good, well, it's good at doing everything. So it's spending a lot of its brain power at being good at things that you don't particularly need it for. So here's a question to think about. And then another one, and one of my favorites, is if you're just wrapping an LLM endpoint, what is preventing others from coming into your market, copying your software, and doing something similar? Of course, there are things preventing it, but still, I think we can all see that it's a bit, yeah, it's a bit easier, right? What would you say,
And
Jeff, about this?
yeah, and Miguel, great point. And so I want to kind of equate this to, like you said, there's a lot of things that you might be able to do with system prompting, or even putting in the regular prompt. However, that could be exposed in different ways to end users, and they potentially could take hours and hours or months of your work. Um, Versus if it's fine tuned, it's really wrapped inside of the new fine tuned model. So think of it as in the programming realm as compiled code versus a script that someone could look at on GitHub, for example.
Exactly, right? And we've heard a bunch of these cases about like people extracting the system prompts out of many products, right? And then you get all of their hard work immediately there, and it's really easy for someone, or easier for someone, to replicate what you have. Okay, so now that we've left you with something to think about, and that we'll mention also in this presentation later on. But for now, I wanted us to go through this real world case, okay, where a company called Checker, I'll present it in a bit. So they use fine tuning, and we got our eyes on this case, and we thought it was great to bring it here to show some of the strengths and weaknesses of fine tuning for specific scenarios and the exact results. Okay, so for example, in this image here, we can see criminal records or background checks. Checker, its goal is to automate these background checks, so a company can check, for example, for its employee, all the background checks over several countries, several states, etc. And one of the most difficult things is that they are filled with legal stuff. Then it's hard to categorize into like how serious something is or not, right? So they want to automate all of this process. So like I was saying, yeah, Checker is a leading company on this, okay? And they have millions of checks being done per month, meaning that the volume is really big, and that's why they really want to automate this. Now, the specific challenge that they tackled was that they wanted to do classification of these charges. Specifically, they wanted to classify each charge that a person may have into 230 categories. Now, this is a lot, as you can imagine, right? If you have 230 categories that you have to make an AI decide on, and you have to tell it in the prompt, all of these, what they are, what are the exact reasons that the thing would be on that category, I think you can already start seeing how big the prompt will get, right? And the bigger it gets, the more confused the AI can also become, etc. Now, like I said, they have a huge amount of checks per month, 1.5 million plus. So this can get really expensive. Plus, it's slow to use these big models, and they were aiming for near real-time experience. So like, I don't know, anything below 2-3 seconds. So with this in mind, they decided to do some experiments, okay, with these LLMs. Now, the first thing they did, which is, of course, I think the most reasonable approach and that everyone does, is, okay, let me just go to a foundational model. I'll put in all the instructions of these categories, all the instructions on what each charge is exactly, and I'll try it out. Well, we can see the ACC here is accuracy, general, so for most use cases. And then we have accuracy harder for their really hard use cases that they categorize as really hard. It actually only represents 2% of the total. Okay, and then we have the response time, which is 15 seconds, and the monthly cost. Now one could say, wow, this looks amazing. 80% plus on all scenarios pretty much, right? This looks great. Why do we need anything else? Now, if you remember what I said previously, they were aiming for near real time. And while 15 seconds is quite fast, it doesn't offer like the interactive experience that a user may want. Plus, they were kind of looking at this monthly cost and seeing if it could be brought down. And if the accuracy on these harder cases could also be brought up, would be something very significant for them. So with this in mind, they did some more experiments. What did they do? They added drag. Now that seems great. What did they manage to do with drag? Instead of giving it 230 categories, now they are only giving it 6 examples that were selected based on drag, which are deemed relevant for that scenario, okay? For that specific person or for that charge. And with this, the accuracy actually improved.
I want to jump in here, Miguel, because I think you're touching on also like a subjective case. So when you're looking at the accuracy harder, so let's talk about checker, and we do not really know how they define their cases for harder cases. But let's say that harder cases would mean applications that they need to verify, and effectively those cases are going to human validation or human inspection. So you may think that, wow, that's amazing. With Gemini 2.5, they just managed to get 81% accuracy out of the box with only prompt engineering. And then what would typically happen is exactly like Jeff said, their competitors might be able to understand how they prompt engineer, and they'd be just able to match that performance, right? So perhaps getting the 80% automation would mean that they're still going to be less effective than their competitors if their competitors applied more sophisticated types of optimization on their AI application. So, it's all depends on if you are 2023 and you're getting 81% automation with LLM, that might have been good, but your competitors are gonna catch up, and then you might need to survive at 95% accuracy. And the question is, how do you get to the 95 accuracy? And also, how do you get that edge on top of these models? So maybe coming back to you.
Yeah, I mean, I think those were great points, right? Like I was saying, this is not all, like you were saying, this is not all objective. It's subjective on the specific use case and the needs, right? And how to keep the edge over the market. And exactly with this in mind, they actually decided to fine-tune a smaller model, which is their next experiment, right? So they actually used the 7 billion model, very small one, but they fine-tuned on all the data that they had previously collected, right? So they had high-quality data from a lot of checks that were done, which humans then evaluated as correct or incorrect. And they managed to only send in the prompt the current charge, right? They don't no longer need to send an explanation of the categories, etc. Why? Because all of this, the model learned while fine-tuning. So the prompt is pretty much being hard-coded into the weights of the model. Therefore, it's much faster, much cheaper. We can see that they achieved like 0.5 seconds per response, a monthly cost much lower, and even more importantly, maybe, a really high accuracy, much higher than before, running a much smaller model. Pretty impressive, I would say.
Yeah, and Miguel, if I can jump in real quick,
Yeah.
the things that stand out for me when I look at what's happening in the field here, the original approach, one of the reasons for the very high cost, and just to reiterate, and for the response time, I still see customers saying that they want to load and make use of the very large context windows of the Gemini models, for example. In some cases, that could be great for rapid prototyping, and if you don't care about latency or cost. But when you're doing millions of checks a month, like Checker is doing, um, we can't forget about bottom line revenue and savings. So it's really important that the savings will be there. Now, when you go ahead and you fine tune, and then of course when you add RAG, that adds much more savings and a lot of speed. There's a high speed database behind it, like it would be, Vector on top of Vertex AI search in Google, which provides a lot of these responses. So the context window doesn't have to get loaded up. And the other great thing here too is the human in the loop factor. They're depending on the use case and depending on the exposure and liability of false positives or negatives for the company. Checker could easily handle a sample set of human in the loop and then even further fine tune depending on the use cases. So, but as you can see here, going from 12,000 to a month to $800 a month, they're clearly keeping that context window small and saving a lot by putting a vector database in there.
Yeah, absolutely. So with this in mind, I just wanted to talk about why exactly was fine tuning so important here and what made it like be especially necessary, right? So like I said previously, these kind of records have a lot of legal jargon, which for some models they may not be so well accustomed to, or the formatting of the documents, etc. So fine tuning helps a lot with that. Also, like Jeff was saying, with the costs and latency, because you will need much smaller prompts. And fine tuning helps a lot with this. Also, with improving accuracy and consistency, like we saw with the results. One of the most interesting points here that I want to touch, and Jeff also mentioned, is that they had humans in the loop. They had humans labeling it, right? And the last point here, so it was trained on proprietary background check records. This is what makes this kind of scenario, this kind of company distinguish itself from the competition. What is preventing another like competitor from coming in and fine-tuning their own model? Well, they may not, or probably won't have exactly the same amount of data that Checker already has, that Checker has been having, labeling, humans labeling it, right, with high quality. And this is what allows then the fine tuning to happen, right? And I think this is what gives them the edge here, which then allows them to get the technological edge. So the results, just recapping, they achieved 90% accuracy overall. They reduced costs by over five times, 30x speed up, okay? A lot more background checks at lower cost, and more importantly, greatest customer satisfaction. And exactly why we see that it's so important and the results is why I want to talk about when is it required. I talked about it a little bit and we talked about it a little bit, but I want to really deep dive into this because I think it may be the most hit or miss scenario where sometimes people will completely avoid fine tuning out of fear or go at it too soon maybe in the process and not have the correct data. I don't know if you've also seen this, Jeff, but it like scenarios where people go at it and then they complain, oh, fine tuning doesn't work that well. Well, but you need good data, right?
Yeah, and I think one of the things to touch on when you spoke about human in the loop, that's actually one of the best sources for where that high quality data gets created.
Yeah, absolutely. So it's about designing the pipeline so that you keep having data labeled as you go. So with this in mind, just a quick recap on some things we said. So fine-tuning can help with LLM tone, enforcing format, for example, if you need JSON or other kind of formatting, hard coding the prompt into the weights, so the prompt gets much smaller and it gets much more clear to the model on what you want, higher accuracy for, and this is important, highly specialized or specific use cases, and adding your specific business context into the model. So for this, now we wanted to present you with kind of a decision framework for whether to fine tune or not that we did. Of course, this is not bulletproof, but it's just to give a general idea of what's the process on a specific project or product, right? So usually you'll start with prompt engineering with a foundational model, and then you'll evaluate the results and you can see, okay, what are the metrics that I care about? Is the cost good enough? Or do I not even care that much about it? What about the latency, the accuracy on all cases or very specific cases? If it works, good, you're done, you can rest, right? But if it doesn't, then a good question is, okay, can you make a fine-tuning data set? High quality data. And doesn't need to be today, but can you make it alongside, let's say, 1 month, 2 months, whatever? Can you have this? If not, maybe the LLM is not going to get there and you may need to rescope. So when I have here, rescope the project, it may just need to be like rescope how you deal with the product of the AI. For example, in Checker's case, if we said, okay, the accuracy is only, say, 50%, then maybe how you rescope this is you put more humans in the loop. Could be an idea, right? But of course, it depends on the use case. But if it works, then fine tuning. But if you can have a data set, then fine tuning is an option. And then you can evaluate to see if it met all of your criteria. And here we also have like some axes to think about, some points to think about. So one of the most important that I was hinting at is how it relates to the business value. So how each metric relates to business value. So how important is it to actually lower costs? Sometimes it may be very important because the scale is huge. Sometimes not so much. Sometimes it's about the latency because you want real-time experience. How does it relate to business value is often the best question to look at. Then you have the second point, you have data quality. Third point, of course, analyze the cost benefit because you will have to invest in not only the machines to train, but you'll have to have engineers looking at it. Then time to market. So if you need a product for tomorrow or in 2 weeks, maybe fine tuning is not the best option if you've never done it before. I think this is the cool thing, which Jeff might agree with me, which is that's the thing. Once you fine tune once, then you pretty much pass this invisible barrier. Then it becomes so much easier to do it again because you already have built this knowledge. So then when you look at time to market, etc., it becomes much faster.
Spot on.
Spot on, right? Yeah, at least that's been my
Yeah.
experience where people
And,
are very scared.
it really goes to if you just think about like SDLC and just the whole model of software development as well. There's a lot of similarities where develop and do your major revision once, then some of the incremental you can handle with prompting, and you're probably not going to be fine tuning extremely often. Uh, think of it as the same way as when large language models are getting built and iterated. It can be a timely process, an expensive process. So again, the quality is where that comes in as well.
Exactly. And like you were saying, Jeff, about how often you may need to fine tune, I think this is like point five, adaptability and flexibility. So for your specific use case, you have to see how much does the use case change throughout time? Will the data change considerably, like every month? If so, maybe fine tuning will have to be fine tuning a model every month or a couple of months. But if the data is pretty much all kind of the same, if it's the same problem, this use case is gonna keep existing for like a year or more, then you fine tune once and you have it. And of course, the competitive analysis, which we hinted at, which is like, how does it distinguish you from the others, from others possibly copying or trying to do something similar? Now, we've been talking a lot about when to use it. Now, I just wanted us to cover a bit some of the pitfalls that people might fall into and go into prompt engineering too soon. So there are times where prompt engineering into fine tuning too soon. So there are times where prompt engineering would have been enough, right? If the use case is constantly changing, you don't know exactly what's going to be in a month. Maybe just use prompt engineering. If it works, if it meets your business metrics, it's great. Sometimes you need additional knowledge. Well, RAG is like the perfect use case for it, right? If you don't have high quality, don't jump into fine tuning. Then we have the flexibility that we already discussed. Then you have to, of course, look at cost benefit analysis. Do you actually have the in-house knowledge for this kind of engineering? Will you outsource it? How will you do this? You have to look at this. Then the sixth point, which is rapid obsolescence risk, which is like, okay, what if I fine tune this model and now suddenly a new model comes out and I spent 7 months fine tuning a model where, well, maybe try not to spend so much time, right? So don't over engineer too much. Then again, is simplify, iterate to small steps. Like Jeff was saying, you can often do the first step and then just iterate a bit, improve this, try out this version, try out this version, instead of being 6 months until the first version.
Absolutely. And just to reiterate again, the data quality is so important, even more so than the quantity of the training examples. And please don't use LLMs to generate the data. You kind of get some circular situations there.
Yeah, then it's like you're just feeding it all over again, everything. Yeah, because then you're gonna get probably very biased results. Best data, real world data. Okay, so now I just wanted to look at again this framework that we just presented, but throughout the lens of the checker use case. Okay, and we saw that they started with prompt engineering, right? If you remember, then they did experiments. They saw the metrics are not good enough. They realized that they already had good data, so they decided to fine tune, right? So we can see that we go through this framework, and it worked perfectly for them because indeed they had a lot of categories, checks like we talked about. And if we look at it through these points that we just talked about, it directly relates to their business value, right? So having a better accuracy here is their core product. So they're effectively improving on their core product a lot. It's not just a gimmicky, right? Gimmicky thing or like a nice to have. And then you can look at all of these other points and you can even reflect on them by yourself. And I do encourage you to do that because it kind of trains you to sort of start having this mentality of questioning things and seeing if fine-tuning actually works there. But the last point, which is competitive analysis, I'm again going to drill down into this. It makes them very distinguished from the competition, the type of accuracy that they manage to have. And going back at some of the initial questions that we asked, which is, does wrapping allow you to tap into the full potential of AI? For example, on this scenario with Checker, it was pretty obvious that, well, it wasn't allowing them, right? And it was the fine-tuning with the high-quality data that allowed them to have the best results.
Miguel, I'm seeing that we're a bit behind time, so I was wondering if you can jump to start to speak about what actually fine-tuning looks like.
Yeah, don't worry. Let's jump there. So, yeah, perfect. So one of the things that I wanted to talk about, and which I think I saw someone in the comments already talking about, is PEFT, parameter efficient fine-tuning. So like I said in the beginning, fine-tuning, you don't need to train all the parameters. You can actually train just a few. Here we have like selected layer, but you can select many from different layers. And then you have other techniques like LoRa, low rank adaptation. Don't get scared by this diagram. I'm not going to go in depth into this. I just left it here so that anyone that wants to research can. But the main idea is that you can train these models, so you can fine tune them with quantized weights, meaning the numbers are less precise, you save a lot of resources, time, etc. So you have ways now to do this with much less costs and time to fine tune. Then we have one of the most interesting things I would say that has come out of fine tuning recently, which is knowledge distillation, and that we've seen a lot of mini and flash models and these kind of smaller models being trained on. And we actually brought a diagram here to show how it can be done, an example. So it looks a bit complex, but the idea is that you have an initial on the left fine-tuning data set. Okay, and maybe it's good, maybe it's not so good, but you want to teach it something. So let's say we want to teach reasoning, high quality reasoning, like complex math problems. So you use a bigger model, a smart model, a very smart model. Can be like Gemini 2.5 Pro here, or another bigger model to generate answers. And then you have question answer pairs. And because it's sometimes questions or answers that you can evaluate, you can immediately reject the wrong answers, right? If it's a math problem, you can evaluate it, you reject the wrong answers, and now you get a fine-tuning data set. And this is key because once you have this high quality data set, you can use it over and over again to train different models for different experiences, different experiments. And you can train a smaller model, whatever it is, and train it on this kind of data set and actually make it smarter sometimes. And this is the knowledge distillation that we've heard so much about. Of course, it's a bit summarized here, but I think it portrays the general idea. Okay, now I wanted to jump a little bit into how to actually fine-tune. And yeah, I think, Jeff, this is where I'll hand it over to you to talk a bit about Vertex AI, Gemini, and how to actually fine-tune.
You're muted, Jeff.
Yeah.
Yep. Okay, I just requested control. Excellent. So thanks so much, Miguel. I'm going to go through some of these pretty quickly, but Vertex AI, I wanted to start by saying we use LoRa, low rank adaptation, for the supervised fine tuning. We find that that is, pretty much a very efficient way to do it versus, retraining the entire model. Um, Okay, great. And I wanted to show you also which models that we support for fine tuning currently. So as you'd expect, these are the Gemini models. Definitely the 2.0 models are also in here. Gemma as well. So if you think about the open source models, we're able to fine tune those. And then finally, our Imagen and some of our special purpose models for medical field. All right. So what can we fine tune? We can fine tune text, images, video, and audio. Now think about the advent of multimodality that Gemini brought upon. So again, we're touching on all the modalities. We're not just fine tuning text models here. Okay, so this is a little bit of an eye chart, but just pay attention to the bold. These are some of the areas that you can fine tune against. Classification, where you're looking for a specific word or phrase. Extractive question and answer, where there's context about the answer and specific information in the phrase that gets in response. Summarization, that's kind of the classic, one of the things of Gen AI, summarize XYZ. And finally, chatting. You want to make sure that your chats are relevant. So these are the general four use cases that we're seeing for fine tuning. Now, in terms of the best practices, as you fine tune, you're definitely going to you will want to look at some of the evaluation. You want to make sure that your models are producing what's expected. That's going to involve experimentation. There is no one great way to do this. There are multiple parameters that you can tune, and it's going to take a few runs for you to figure out how to do that. And then, as Miguel was saying, you might not need the largest model. Once you get it correct, you might fine tune a larger model, and then you can experiment by fine tuning one of the flash models or even one of the smaller open source models, and you might get the results that you want. Monitoring is key. You want to make sure that what is coming out of your fine tuning and the responses that people are getting to the requests, you want to make sure it's on par. So when you think about training data, I'm not going to talk about everything here, but you want to make sure there is high quality there. The best way to get high quality is through the iteration of human in the loop. You want to get those the questions, the prompts, and then the responses that are coming back out. So in general, training format
Maybe,
matches a yep.
maybe it's just like I think that this number could be shocking for some people that have not done fine tuning in the past. Yeah, the previous slide, are you actually saying that I just need a few hundreds, like 100 to 500 samples in order to create fine tuning?
Yeah, exactly. So don't fine tune with 20, don't fine tune with 10. Through basically DeepMind from Google is recommending you definitely want to be for these types of fine tuning, you want to be in the 100 plus range. That's where uh, anything below that, you're not going to get great results. Look, as I was saying before, you can fine tune with 20. I don't know if you're going to get the production and enterprise grade results that you would expect.
I think it's quite amazing because again, it emphasizes the difference between model training, where you're actually trying to teach the AI, the LLM, new capabilities to bringing knowledge into the data to really, change the parameters to learn the representation of the world. Whereas with fine tuning, you basically, if it's done properly, you'd need about 100 to 500 examples in order to kind of tweak the LLM behavior. So you don't really need masses of data as you would need for even for training a simple convolutional network to identify cats and dogs in more simple models.
Yeah,
Absolutely.
and Gav, I think this is where I would say because it's only 100 examples or 200, you need high quality data and you really don't want to have noise because having noise is like a big percentage of your data set. So you want to clean it up as much as you can, right?
Absolutely. Okay. So the training format, it's as you'd imagine, it's JSON-L. So basically a bunch of JSON lines inside of a single file. You can have the three typical roles that you already have when you are doing regular prompting. So the system, user, and then the model response. So the model response is actually the label, and the two different roles for system and user are the inputs. Now, this is where we get into the configuration. So there are different hyperparameters that you can tune. Um, Basically, there's epic, batch size, and learning rate. So the batch size, it determines the number of examples that go into each batch. This is a little bit more on the engineering side based upon the amount of memory that you have available and the types of CPUs, TPUs, or GPUs. The learning rate is essentially how quickly that you ideally would want the model to converge. You have to be careful with the learning rate because you can actually go in the opposite direction and not actually get to convergence. And the smaller the learning rate, that's where you will have many more iterations. So you're going to have to do some trial and error and really make sure that you're looking at the results as you go to determine the optimal batch sizes. Great. And here's just another view. What do the hyperparameters look like inside of some Python code from the SDK perspective? So we're going to start getting into the SDK examples, and you will see here that this is fairly common Python. This is from actually an example Python notebook where you are importing in some of the Google libraries for fine tuning. And next, we will, sorry, there we go. Next slide. Ah, okay, something is not rendering. Okay, here we go. So the loss curve. So this goes into what I was talking about before. And the loss curve is also something that you use when you're doing normal training of models. It's essentially how quickly you're going to get to the point where there's minimal loss, meaning the answers that you're getting back are exactly the answers that you want. So interestingly, in this example, you could see that there's diminishing returns to be training past 4 epochs. So theoretically, you could run this training job again with fewer epochs as long as the loss curve is still approaching 0. And this might give you a chance to fix that variable and start working on modifying some of the other hyperparameters. Now, evaluation is super important. There's a couple ways to do this. Autometrics. So think of these as ways based upon specific types of fine tuning that you can measure the outcomes against what you're expecting. One of my favorites is model-based metrics. So think of this as two dueling models. So you have your fine-tuned model, which is running the evaluations against your validation set or production traffic, and then you have another LLM. And please don't use the same LLM. You have another LLM which is also evaluating it, and you can actually see the results against one another. So in some cases, you might be able to get away with this in addition to human in the loop. So it really depends on your risk threshold and what you're actually doing as a company. And finally, human evaluation, as we were talking about for the checker example, there will be a subset, and potentially based on some of the scores for the evaluation metrics of rouge or blue, you might decide to kick some of those or a sample set of those to humans to start looking at the outputs, and then again what they're looking at is going to be training the data for your next fine-tuning run. So let's walk through what actually happens. So I'm going to start with the SDK demo. Again, these are publicly available. You'll get the links to these. I'll make sure that they're available to you guys. And what you're going to see here is essentially what's getting executed in a Python notebook. So Vertex AI, think of this as a platform which can handle all the LLM ops. It is the Google platform for everything Gen AI and LLM. It's able to cover everything from prototyping, from agents to the tooling, backend data repositories, and ultimately down at the bottom, you'll also see the fine tuning. So again, think of this as your go-to location to not only run your experiments, but to go live with your endpoints, exposing those new fine-tuned models to production. So Vertex AI also includes Colab Enterprise. So again, this is where your notebooks are going to run. I'm sure many people are familiar with Jupyter Notebooks. We also have a free Colab version. If you're using the Colab Enterprise version, you get a lot more functionality related to the machine types and the processing types, CPU, TPU, GPU, run durations. You can schedule these jobs to get triggered based upon if you really want to automate the life cycle of your fine tuning, for example. You also get Gemini to help you along the way, which is great. And then enterprise class compliance and security. So if you're handling anything that is part of a regulated environment, if you're going to have regulated customers, they're going to ask you how you're training and how you're doing your fine tuning. Okay, so I'll pause here for a second. You can scan this. Again, you will be provided the links after the presentation. So here we go. So the training data, um, this is synthetic data which was generated. And again, I'm going to say synthetic, and you'll see what's going to happen with it. I don't want to spoil it. But again, this is common JSON where you will be loading this in for your training activities. So what does this actually look like? In this example, we're going to be fine tuning a model that is going to be analyzing pictures. So in this case, we can see that there's a user portion. We're analyzing pictures, file URL, the text of let's describe this image, and then here's what the model is going to be responding with, where it's coming back with a summary. So again, this is the ideal output that we're looking for. So as the model gets fine-tuned, if everything goes well, it's going to be matching this kind of output relative to tone, the size of the content, how many sentences, the specificity. Um, Before you fine tune, you definitely want a baseline. So what you're going to do is you're going to be running a sample of your data, which will be the validation data, against the model before it's fine tuned. That is what we're going to compare it against after the fine tuning, just to measure your progress. So again, for summarization, which is what we're doing, we're going to be using a metric called Rouge. And what I did is I ran all of the validation data against the model without fine tuning first. And so I baseline some of these numbers for precision and recall. Next, this is a lot of code here, but really what we're doing, we're taking everything that we've spoken about already, and we're going and generating the job. As you can see here, here's the training JSON and the validation JSON data, some of the different hyperparameters I was talking about here. And the really cool thing is when you're running this inside of the notebook, if you go ahead and click on the View Tuning Job button, it'll take you into the Google console, and you can actually look at the training job and look for some different progress. So even though you're using the SDK, everything that you're doing will make its way into the Google console if you want to look at it later visually. Okay, so the training job ran, and as you can see here, we only had 0.34%, so a third of a percent improvement for our precision. And actually, we had a drop in recall. So why is that? Again, this was synthetic data. This was LLM generated data. There are some other things that you can try to improve, and because in a lot of cases, you will have to do trial and error. Again, adding better quantity or quality of training samples, playing around with the hyperparameters, looking at your loss curve to determine if you need to run more epochs. And again, different prompt structures. So think of that as the same type of methodology you would be using if you were trying to do prompting engineering to try to get better outputs.
And Jeff, just one question
Yes.
before. Yeah.
Mhm.
So all these numbers and things that you have a lot of steps here, and you had to do this and that, and etc. It all seems very scary, but it's kind of what we were talking about, right? Where once your engineering team does this once and really understands what each thing does, it becomes a lot simpler. How easy would you say that it is after you've done it once or twice to fine tune a new model?
So in general, this goes back to everything will be sitting inside of the Python notebook and version controlled. So once you get it right, you will be able to see how you got there. The traceability is going to be there. Then at that point, it becomes iterative. I don't want to give away how simple this is going to be in the cloud console in Vertex AI, but I'm going to show that to you shortly. And I think that will do away with a lot of some of the intimidation, let's say.
Makes sense. Makes sense.
Okay, so I'm going to go ahead and hand it back to you, Miguel.
Yeah, thank you. Thank you so much, Jeff. Yeah, so with all this that Stefan has been presenting, we just wanted to give some more general advice on fine-tuning, especially for the first times that you do it. Um, I think personally that one of the biggest steps is actually choosing a good architecture for fine-tuning. So this doesn't mean there are particularly bad ones, but there are ones which are more complex. So if you go for dense architectures, which is the most common ones out there for models that people usually fine tune, they are more stable, they are more predictable, there's more community support for them. If you go for more complex models, like the Mistral or the DeepSeek V3, etc., it may be very hard to train because they are harder to converge on. We actually have some blog posts on these kind of architectures, and you can see that they are much more complex. So they might not be the best scenario for you, especially in the beginning. Second thing is picking a narrow scope. And this is very important, which is picking something that is really key to your problem and only focusing on that. And going back to some of the things that Jeff also talked about and presented, the number of epochs, the sequence length, the batch size, right? So all of this, you want to always try to make your VRAM usage the highest possible without passing the limit, without overheating. So you want the batch size big, the context big, really trying to use the most out of the GPUs that you're paying for. And then, of course, the LoRa, which is the only training some of these parameters, rank 16 to 64 or 32 is good. You'll learn a lot about this as you go, right? And for larger data sets, you may need less epochs. For smaller ones, you may need more. But this is just some general guidelines that you can start experimenting by. Yeah. And okay, I think you can move to the next slide. I'm not. I don't think I have the controls now.
Yeah, I think Jeff is up
Yep.
next.
Okay, awesome.
Okay, great. So I'm just going to go ahead and share my screen real quick. We just need to break out of this presentation so I can go ahead and share mine.
So Dan, if you can stop sharing.
Yeah, excellent. Okay. Wonderful. So there we go. God, you're able to see the screen okay?
Yeah, looks wonderful.
Excellent. Excellent. Okay, great. So here we are. We're in the Google Cloud Console, and we're inside of Vertex AI. So in Vertex AI, there's an option to go down to tuning. And the really cool thing here is I called the job that I previously ran with the Python notebooks SDK. And everything I did in there went ahead and loaded up inside of the console. Uh, Again, you can go ahead and look at the tuning progress as it's happening, but once it's completed, you can see that it succeeded. You can see a lot of information about prediction numbers. And again, here's that loss curve. It never really went down to zero. It kind of went off and probably to infinity, it would never get there. Um, but if you want to have some information on the data sets, it's really great because it tells you how many messages are in there, token counts. It gives you an output of some of the rows that are in that JSON-L, distributions about the token count. It's a lot of great information in here to help you iterate. And then finally, you can see all the details of what actually happened. You can take a look at the experiments. You have links to where the data sets are on Google Cloud Storage. So with that being said, what if I wanted to actually run a job inside of the Google Cloud Console? So here, I'm clicking Create Tune Model. And these are the choices that I have here. In the SDK, you can do, in Python, you can do the other models that I spoke about. But as you can see here, we have the full complement of 1 through 2.0, which are currently available. So for this one, let's say I'm going to do flashlight. You choose a region. You can expand advanced options and probably as you imagine, hey, here are some of those parameters, the number of epochs, the learning rate multiplier, adapter sizing, or you can just leave that alone. You don't have to expand it. Again, back to some of the enterprise aspects here, you can go ahead and use Google Managed Keys or a KMS. And then we're going to continue for our, so we're going to look at the cloud storage. And if we look here, you can go ahead and look at the training data, pull that in. And then, yes, we do want to validate because then we can see how we did. And you go into the validation, select that JSON, and that's it. You start tuning. So again, this will take probably around 45 minutes, a similar amount of time it took on in the Python notebook. But I really wanted to show you how quickly you could go ahead and take advantage of that tuning.
I love this one
So
because I think a lot of the companies that we work with, when they hear fine tuning, they think about like setting up a heavy infrastructure handling GPUs, and like where do you start? Where do you? So I think it gives you a very, very quick understanding of what can fine-tuning do for you and how quickly you can set it up. So how, how
Yeah.
much how much time did it take you? Like about 2 minutes that you've been on this page and you launched the fine-tuning.
Barely, barely. And again, if you really wanted to, you could set this up either using the Python notebook once you get everything correct, or you could use the G Cloud command line. So that really wouldn't be too many lines either. Either way, if you're going to do the SDK or G Cloud commands, go ahead and store that in CI/CD. Get that into a version control repository, and then think of that as a huge part of your LLM operations process. All right. So we're not going to watch that run, but I'm going to stop sharing now. Ah, it looks like it already did. Great.
Okay, so maybe just last note about future of fine-tuning. Even though we've reduced the number of samples that you need in order to do fine-tuning to very, very few, sometimes it is hard to create these very, very high quality samples, mostly because of the high quality in them, right? You kind of need to collect these samples that represent enough the domain or the space that you're trying to fine tune into. And if you haven't collected enough samples, maybe you're not going to get the result that you want. So the question is, how are you actually going to do this without even collecting these samples? And in many cases, what you can do is you can, at lower cost, evaluate the results of your fine-tuned LLM. Jeff talked about several methods to do that, maybe using different models, maybe using even a deterministic function. So think about you're trying to fine tune an LLM to give you a structured output, like a JSON. It's very easy to validate if you got a proper JSON, but it might be very difficult to produce it, right? So producing the JSON could be difficult. Validating that you got a JSON is quite easy. So here's a solution for you. I can basically create an evaluator of the AI and essentially do the fine tuning while giving feedback to each and every response. And what it turns out to be is if you're using this method, sometimes you can reduce the amount of data that you need to maybe a handful of examples. So talking about 5, 10 examples in this more advanced technique. And I do believe that will be, so Jeff cannot comment here on what's going to come out, but I do believe that you will be seeing these techniques coming both to Vertex AI and other platforms. So if you think about the future of fine-tuning, I do expect to see some more sophisticated ways to even reduce further the amount of data and helping you generate high quality data using using feedback mechanisms. That's it. If you have any questions, you can still drop them here. We'd be happy to stay for a few minutes and just like answer. Everybody who signed up for this one will get a link to the YouTube recording that we have. It's also live on YouTube, so you can go and check it out. It's going to stay there and on the same link. We're going to send you some of the links that we mentioned. Jeff, I already see that, put it in the chat. And if you do want to discuss your fine-tuning use case, TensorOps is here together with Google to support you in that. So do drop us an email or go to our website, and we'll be happy to see if TensorOps and Google can together help you set up your fine-tuning for your use case. So any questions? Anybody want to ask something? Right. So if that's the case, again, thank you so much, and we'll hope to see you in the next webinars. What is our business model? We can discuss it, but effectively it's services, and there is a potential for collaboration with Google, bringing in their resources. So the idea is in that regard to help you build your workloads on top of Google Cloud, assuming that if you benefit from the platform, Google can make the extra effort together with TensorOps to kind of help you accelerate your adoption of fine-tuning. Right. Thank you so much, everyone.
Yeah,
Thanks,
thank you.
everyone.
Thank you all.